Hello everyone, so today we're going to learn experimental probabilities. But before we learn how to find experimental probabilities, let us talk about what probabilities are. So probability is the likelihood that the event will occur. So when we calculate the probability of an event, the values will range from 0 to 1. So these values can be written as decimals, fractions, or percent. Okay, so if the probability is 1, okay, then probability of 1 can be written as 1 as a fraction or 100% as a percentage. So probability of 0 can be written as 0 as a fraction or 0% as a percentage. Also, zero point 0.5 probability can be expressed as 1 half or 50%. Okay? Now, what do these numbers mean? So if something has probability of 1, okay, then um, we can say that there is a strong chance, okay, that the event will occur. Or we can say that we are certain that this event will occur, okay. Now, if the probability is 0, okay, then it means that the event is impossible to happen. Okay, while getting a probability of zero point 0.5 or 1 half, so which means that there is a 50-50 chance that the event will happen. Okay? Now, to guide you in learning probabilities, let us discuss some key terms. So, the number of trials is the total number of times the experiment is repeated. So, how many times you did the experiment. Okay, the outcomes are different results possible for one trial of the experiment. The frequency of particular outcome is the number of times that this outcome is observed, and the relative frequency is the ratio of the frequency of an outcome to the number of trials. Now, the connection between the relative frequency and experimental probability is that to calculate the experimental probability, that is equivalent to the relative frequency of an event. Okay, so we can say that the probability of an event is equals to the number of times the event occur over the total number of trials. So calculating the relative frequency of an event is also equivalent to calculating its experimental probability. Okay, so basic applications of experimental probabilities are events involving rolling a die, tossing a coin, or even on a spinner. Okay, let me show you an example on how we calculate experimental probability using the relative frequency. Suppose that the experiment is tossing a coin one time. Okay. Now, to find the outcome, we need to find the possible results of tossing a coin. Okay. So, the possible results in tossing a coin is either heads or tails. Okay. So, that is our outcome. Now, let's say we're going to repeat the experiment for 5 times. Okay. And we record the results using this table. Let's say that on the first trial, the coin lands on head. On the second trial, it lands on tail, then tail again. And then on the fourth trial, we got a head and then another head. Okay. So we can summarize this table by counting the frequency of each outcome. So the outcomes are head and tail. So we got three heads and two tails. Okay, so we can generate a table like this. Okay, so that we can easily calculate the relative frequency. So in the previous table, we had three heads and and two tails. Okay. Okay. Now, if we want to calculate the probability of each outcome, then we need to get its relative frequency. Okay. Remember, the total number of trials, okay, is five. So to calculate the relative frequency, we will divide each frequency of each outcome. Okay. So the relative frequency of getting ahead is 3 over 5, or in decimal, 0.6. Okay. And and the relative frequency of getting a tail is 2 over 5, or 0.4. Since the relative frequency of an outcome is equal to the experimental probability of an event, then we can say that the estimated probability that the coin will land on head, okay, is 0.6, or 60%. And the probability that the coin will land on tails is 0.4, or 40%. Okay, so that's how you calculate the experimental probability of a particular outcome. Okay, let's have another example. Suppose we roll a die 100 times and we recorded the results using this table. Okay, now let's answer the following question. Estimate the probability of rolling a tree. Okay, so based on the frequency table, the total number of trials is 100. Okay, and the frequency of occurring tree is 22 times. Okay, so to estimate the probability of rolling a tree, we will get its relative frequency. So the probability of getting a tree will be the relative frequency of getting a tree. Okay, so that will be 22 over 100, or in simplest form, that is 11 over 50, or we can also write it as a percent, which is equivalent to 22%. So after we compute the probability, we need to write the conclusion. So we can say that there is a 22% chance that the result will be 3. Okay, next problem. Estimate the probability of rolling a number less than 4. Okay, so based on the table, the numbers less than 4 are 1, 2, and 3. Okay, so what we will do is to add all their frequency. Okay, so 16 plus 20 is 36 plus 22 is 58. Okay, so to find the probability that the number will be less than 4 is to divide the sum of the frequencies by the total number of trials. So since the sum of 1, 2, and 3 is 58, and the total number of trials is to 100. So the probability of rolling a number less than 4 is 58 over 100 or 29 over 50, or in percentage, that is 58%. Okay? So we can say that the probability of rolling a number less than 4, okay, sorry, this should be 4, is 58%. Okay, so let's have our last question. So estimate the probability of rolling a 2 or 5. So this problem is similar to the previous question. Okay, so what we will do is to add the frequency of rolling a 2 and rolling a 5. So 20 plus 18 is 38. Okay, so the probability of getting a 2 or 5 will be the sum of the frequency of 2 and 5 divided by the total number of trials. So 38 over 100. Okay, so in simplest form, that is 19 over 50, or in percentage, that is 38%. Okay, so in conclusion, there is a 38% chance of rolling a 2 or 5. Okay, so that's how to calculate experimental probability. Remember, in calculating the experimental probability of an event, you divide the number of times an event occurred by the total number of trials. Okay, so that's it for today. I'll see you in my next class. Goodbye.